Hello everyone, welcome back to Algebra 1 with Miss Betsy. Today is video 3 of a 3-part series where I have been working through problems where we use two variables to solve interest problems. If you are using the same text that I am, I'm in Chapter 7, Section 8, Interest Problems. I'm on page 306. The book is Algebra 1 by Christian Schools. It's published by Bob Jones University Press. I'm currently using the second edition. This is our final problem, so let's dive right into it after I ask you this riddle. Now it's fairly early in the morning where I am now. I'm slowly getting my brain working. See if yours is working. I have two coins in my hand. One of them is not a penny. Together they total 6 cents. Can you tell me what two coins I have in my hand? And yes, they're United States coins. Well, I have a penny and a nickel in my hand. All I said was that one of those coins was not a penny. I didn't tell you that both of them were not a penny. Okay, example 3, page 306. Mike is going to make two investments, and he knows he will receive $770 in interest per year. The interest rate on the $5,000 investment is 1% higher than on the $4,000 investment. What is the interest rate for each investment? Well, you can see that I've already put my chart up here. I have the first investment, I have the second investment. Principal times rate times time is equal to interest. It's time to go ahead and identify, define what we're going to use our variables for, fill in our chart, and then we can come up with two equations that we're going to solve simultaneously. First, what do we want x and y to be? Refer back to the problem and see what they're asking for. The last sentence says, what is the interest rate for each investment? So let's have x be the interest rate for the first investment. And how much money is invested at that? Well, we're going to say that that investment there is $4,000. The second variable is going to be the second interest rate, and that is going to be the amount of money, the interest rate on the $5,000 investment. $4,000 and $5,000. Now, our first column right here to fill in is really easy now. What's the principal? Principal is the amount of money that's being invested. We just said we have $4,000 invested and we have $5,000 invested. What's our rate? We don't know what our rate is, but we have defined the rate on the first investment to be x. The rate on the second investment then is y. How long has this money been invested? Our book tells us that Mike is going to receive interest per year. So this money is going to be invested for a year. How do you calculate interest? Interest is equal to principal times rate times time. So the interest on the first investment is $4,000. The interest on the second investment is $5,000. Our chart's filled in. What we want to do now is go ahead and come up with two equations that are true based on the information given to us in our text, where we can solve those simultaneously. First sentence, it says, he knows he will receive $770 on interest per year. The total interest is always going to be equal to the combined little pieces of interest. So if you have the interest on the first investment is 4,000 times K, you add the interest on the second investment, which is 5,000 times K, and you end up with the total amount of money that you receive in interest income of $770. Usually when you're working these word problems in two variables, one of the equations just absolutely leaps off the page at you. Now the second piece of information is contained in this. It says the interest on $5,000 is 1% higher than the interest on $4,000. Now there are a variety of ways that you could come up with an equation representing that relationship between the two interest rates. I'm going to go ahead and refer back to this book because I want to show you what their thinking is. It may be the very first place that many of you go and you're thinking that's not what I immediately think. So let's go ahead and see what they come up with. They have written that y minus x is equal to 0.01. You see how I keep doing the k's here? This is really 4,000 times x, 5,000 times y. I'm sure you were wishing that you could come through that video screen, through your iPad, and say, I think you don't mean to put k. You're right, I didn't mean to put k. 4,000x, 5,000y, and see I'm getting ready to do k again. 4,000x, 5,000y. What they're saying here is the difference between the two interest rates is 1%. For example, if the interest rate on the second investment is 6%, and that is 1% higher than the other interest rate, 6% minus 1% is 5%, isn't it? Right here, what I said was that the interest on the y, the way that I ended up making that equal, the interest on the second investment, the way that I equalized that with the investment from the first, since it was greater, I subtracted some. That's one way to look at it. And here you would have y minus 0.01 is equal to x. Okay. Another way to look at this would be to make both sides of the equation represent the interest rate of the smaller interest rate. So if you had the smaller interest rate, let's say was 5%, and you added 1% to it, then you would have the larger interest rate, wouldn't you? You would have x plus 0.01 is equal to y. Okay? Got too many different, all the same color here. I want to go ahead and put these in red because I'm not able to not show you the different ways that you can approach this problem. Y minus 0.01 is equal to x. Here I have x plus 0.01 is equal to y. Now, of these two equations, two different ways of looking at it, what I've done is I've taken the second interest rate, which was higher, reduced that to equal the first rate. Here I took the first interest rate, which is lower, increased it so that it equals the second interest rate. What did they do here? They said that if there is a difference of 1% between those two interest rates, that's what they've done here. This is where they have keyed in on the difference of the interest rates is 1% of interest rates is 1%. Okay. And then, when they got to this point, they went ahead and solved for y. See what I have down here? I have already that y is equal to x plus 0.1. That's what they did. Let's go ahead and erase this and I'll show you. I have this equation, this relationship that they've set up that says the difference of the two interest rates is equal to 0.01, and they're thinking, oh, if I solve for y, then I can just substitute and that'll make the problem pretty straightforward. So what do? You add an x to both sides of the equation, and you now have y is equal to x plus 0.01. We have a value that we can substitute in here for y in our first equation. So let's go ahead and do that. We're going to have 4,000x plus 5,000 times our value for y, which is x plus 0.01, and that's going to be equal to 770. Okay? Going to multiply. Four thousand x plus, we're distributing 5,000 times x, plus 5,000 times 0.001. Move our decimal point 2 units to the left because we're multiplying by 100. So that is equal to 50. Is equal to 770. Now we simply do our arithmetic. 9,000x is equal to 7,200. I said 7,200, I'm sorry, $720. Now, we're going to divide both sides of this equation by 9,000. This is a point. Go ahead and get your calculators out. And you will see that x is going to be equal to 8%. Yes. X is equal to 8%, 0.08. Because what you actually have, you can divide, you can cancel tens. 72 divided by 900. 8 times 9 is 72. So the interest rate on the 4% investment is 8. The interest rate, 8%. The interest rate on the second investment is 9%. 0.09% at 4K. 0.8% at 4K, 0.9 at 5K. Now, you heard me speak it incorrectly. I also wrote it incorrectly. This here says 1/8%. You either write it 0.08, which indicates that you have a percent interest rate of 8%. Or you write 9%. You don't do that ridiculous bit that I had right there where it said 0.08%, because that's not what you're talking about. So when you do your division, you get 0.08, which is written as we commonly understand it, 8%. That's the solution to this problem and the conclusion to the 3 video series where we're working interest problems in 2 variables. I'll see you next time.